So, once we talk about derivative, so derivative is just a gradient of that function. Okay, derivative is a gradient of function.
Yes, sir.
So, in terms of limit, derivative is a gradient. Okay, gradient or slope of the function at particular point. Like if this is your function and you want to find its derivative at this point, so just find its tangent and the slope. This, if this is theta, so m equal to tan theta is the slope of this graph at this particular point. Let us say it is p, isn't it?
Yes, sir.
So gradient is basically your slope at that particular point. Got it?
Okay, sir.
So in terms of its definition, so your gradient in terms of limit, if you define it in terms of limit, so limit h tends to 0, f a plus h minus f a divided by h. Okay,
Yes, sir.
so that is called as derivative of fx at a. At point A, derivative of fx is f a plus h minus f a divided by h once limit h tending to 0. Okay,
Yes, sir.
so it is called as its derivative, and it is just symbolically we write it like f dash a. This one can be written as f dash a. F dash means it's a derivative with respect to derivative at point A. Okay,
Yes, sir.
just write it down, we'll see there. Please note it down, because we'll use once we find derivative of a function.
Yes, sir. Sir, this works in the case of trigonometric identities also, right?
Yeah, there may be any function.
Okay.
It will be applicable for all functions. Okay.
Okay.
Okay. So now by using that, this formula, just find the derivative at x equal to 2 of the function fx equal to 3x. Just find it. Should I do it for you?
I'll try doing it.
Okay, I'll use you try it. Please try. At place of a, 2 is there. Okay.
Okay, sir. Yeah. 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 Yeah.
Done.
1 second, sir. Sir, I'm getting that whole number by 0. I'm getting 3.
Yeah, 3 will be the answer.
But I'm getting it by 0. Like this kind guessing.
Just will apply that formula. Your fx is 3x. So f dash, if you want to find f dash 2. So f dash limit h tending to 0 f2 plus h minus f2 divided by h. Okay.
Yes, sir.
Limit h tends to 0 f2 plus h. So at place of x,
I got 6 plus 3h.
3 2 plus h minus f2 will be 6 divided by h. So limit h tending to 0, 6 plus 3h minus 6.
Wait, sir. Never mind, I got right one.
So h cancelled, limit h tending to 0, 3. So that will be 3.
Sir, I got correct one.
Okay. Got it now?
Yes, sir.
Okay. So similarly you can do more questions. Your next question is that one. Just try to do it. Example 6.
Sir, is it 7?
No, it's not 7.
Huh?
It's not 7. it is not finding about what you got as f dash 0. Okay, at x tend x equal to minus 1. It is not 7.
Okay, no.
F dash minus 1 will be equals to limit h tends to 0 f minus 1 plus h minus f minus 1 divided by h. Okay,
Yes, sir.
so limit h tends to 0 minus 1 plus h, so you'll put into this 2x square plus 3x minus 5, so minus 1 plus h 2 into this square plus 3 into minus 1 plus h minus 5, and what is the value of f minus 1? F minus 1 will be 2 minus 3 minus 5, so it will be minus 6. Okay,
Yes, sir.
so minus 6 and divided by h, so limit h tends to 0, just open the bracket, 2 into 1 plus h square minus 2h, it will be minus 3 plus 3h minus 11 divided by h, so that will be limit h tends to 0, 2 plus 2h square minus 4h minus 3 plus 3h minus 11 divided by h. Okay,
Yes, sir.
so that can be written as 2 minus 3, that is minus 1, and minus 11, that is minus 12. So that basically becomes limit h tends to 0, 2h
Sir,
square.
I did properly only, but like instead of minus 4h, I wrote plus 4h, so I got 7. Like I got 2h minus 7 instead of 2h minus 1.
Okay, so that will be 2h square minus h minus 12.
Yes, sir.
Okay,
Okay.
yeah, I think we are doing some mistake. That 12 will not be there.
Sir, there's no 12, sir.
That 12 should not be
Then
there.
how did you get 11, sir?
Just a moment, it is minus 5 already, and what is the value of f?
Sir, shouldn't minus 6 be plus 6?
Okay, that negative is also inside, outside, so that will not be there. Okay,
Yes, sir.
that number will not be there, any number will not be there, 6 will be cancelled, so that will be only 2h square minus h, so just divided by h, so that will be limit h tends to 0, 2h minus 1. Okay, if you put h as 0, so you'll get it minus 1, so the value will be negative 1. Okay,
Yes, sir.
like this you need to do. So that f dash minus 1, you will get it minus 1, this one. Similarly, just find out f dash 0.
Uh,
The same way,
Sir, got it, sir.
Okay. Okay, now do the next one. Yeah, this one. Find the derivative of sin x at x equal to 0.
Sir, is it 1?
Yeah, it is 1. Good. Now find the derivative of fx equal to 3 at x equal to 0 and x equal to 3.
Sir, because it's a constant, will be this. If f of x is 3, then f of x plus h is also 3 only.
Yeah. This is called
Sir,
as,
is it 0?
yeah, it will be 0. So that means the derivative of a constant function will be 0. Okay.
Yes, sir. Yes, sir.
Okay, the next one. Let it be any point, but the constant function will have always its derivative as 0. Yeah. So if you want to find simply derivative with respect to x. Okay.
Yes, sir.
So derivative is basically, if I am writing a function fx, so what is its derivative? This is y equal to fx, so its derivative will be dy by dx, or I can write it like d by dx of fx. Okay, so that is the basically dy by dx, it's a derivative of y with respect to x. Okay, so we just say it, derivative of y with respect to x, we call it like this. Okay,
Yes, sir.
so we write it like f dash x also. So f dash x will be always this one. Okay. Now we are not finding derivative at a particular point, we are just finding derivative with respect to x. So it's a general derivative, it's not about at any particular point. Okay, just write down, then we'll see some questions based upon this. Okay, that is the same thing, because at place of a we have replaced a with x only, isn't it? Just note it down. This one is also written as dy by dx, or we can write it d by dx of fx. Done? Okay. Now just find the derivative of 10x. Okay, now it's not about a particular point.
Yes. So is it 10?
Yeah, it will be 10. Okay.
Yes, sir.
Yeah, now just find the derivative of fx x square.
So 2x.
Yeah, it will be 2x. Great. Constant function this time. Fx equal to a.
Sir, it will be 0 only, right?
Yeah, differentiation of a constant function is always 0. Next one, it is 1 by x this time.
Sir, I'm sorry for the commotion. Like, cousins over, so.
Sorry?
I'm sorry for the commotion outside. I don't know if you're listening.
What?
I'm saying I'm sorry for the commotion outside. My side, on my side.
No, I didn't understand what you're saying.
The commotion, I'm saying the noise from my side.
Commercial?
Yeah, the noise from my side.
Okay. No, I'm not getting it.
Yeah.
I'm not getting any noise from your side.
Oh, okay, sir.
Okay. If you have a digital laptop, it always cancel it, the surroundings. You know, I have taken online class by sitting on a platform. So
Very noisy for you.
yeah,
Not the other person also.
it
You
is
feel
it
very.
is it is noisy for me, but not noisy for the person who is attending the class. But it is very difficult. But sometimes we have to
Yes, sir.
bear this if it is not avoidable.
Yes, sir.
So the thing is, if you are using mic that headphone, so
Yes.
headphone just cancels all outside noise.
Yes, sir.
Our class will be ending in 5 minutes automatically.
Yes, sir.
Because it can be maximum up to 1 hour 20 minutes.
Yes, sir.
And even you can take benefit of my YouTube channel.
Yes, sir.
You can take benefit of my YouTube channel also. It is
Yes, sir.
it is mathkingmaker, so you can go over there and you can see all the your 11th lectures there.
Yes, sir.
And there are physics lectures also available there.
Yes, sir. There is a 1 by x square, negative 1 by x square.
Yeah, it is negative 1 by x square. You are right. Yeah, it is negative 1 by x square. So similarly you can find all the derivatives. Okay, now algebra of derivative of functions. So that is very simple. If you have sum of two functions, then it can be differentiated separately. Okay, if it's a negative sign in between, then you can do it like write it the same way and manner. If you have multiplication is different thing in case of differentiation. Okay,
Yes, sir.
so once you do multiplication, then the first function is differentiated and second function as it is you have to write, and plus second function as it is, the first function as it is, and differentiation of the second function. Okay, that is called as the product rule of differentiation. And the quotient rule is quite different, because if fx by gx, so you will write differentiation of fx into gx as it is minus fx and differentiation of gx, and now in denominator gx whole square. Just write down these two formulae. Okay,
Yes, sir.
just note it down, because if somewhere you find the product and quotient of two functions, then you have to use this rule. This one is product rule, this one is quotient rule. And the condition in the quotient rule, your denominator must not be 0.
Okay.
Noted?
Yes, sir.
So basically it is written as uv differentiation. So uv differentiation is u dash v plus uv dash, where u and v are the two functions. That is referred to as a Leibniz rule for differentiating product of functions, or the product rule. Okay, so that is also called as Leibniz rule. You will see it in higher classes. So similarly u by v dash is u dash v minus uv dash divided by v square. Okay, so this one, if you find derivative of x to the power n, so you will get it n x to the power n minus 1. So just do all the questions, whatever is there, theorem number 6, you have to do it at your own. Okay, all the formulae. So this is basically called as derivative by first principle. Okay, it is called as derivative by first principle. So these formulae, all formulae of derivatives are derived by that first principles only. Okay,
Yes, sir.
so these theorems you just try to prove it, whatever theorem questions are there in this exercise, and if you have any doubt, then we'll do it in the next session. Okay,
Sir, can you repeat what you said?
yeah, whatever theorem and questions are there in examples, you have to do it all.
Yes, sir.
Okay, at your own, by the first principle only, and if you have any doubt, we'll clarify it in the next session.
Okay.
Okay, and try to do exercise also, all examples,
Yes, sir.
all theorems, exercise. Then
Yes, sir.
we'll have session at Friday 8 p.m. Okay,
Yes, sir.
okay, then bye bye.
Thank you, sir.
Bye, see you.